first thing first, what you are going to do, I've said it before and I will still keep on saying it. Whenever you are given a question, generally, your interest should be your parameters, right? Now, from that question, we are given that a block weighing a block weighing 1500 Newton rests on a plane inclined at 20 degrees to the horizontal. Right? Now, let's give that question a schematic illustration. Are you with me? Now, I believe we understood the concept if we have something inclined. What we discussed earlier, when we look at the concept of coefficient of friction, we call coefficient of friction. We said, let's say we have a block, a block on this rough surface, or you say a body, right? Now, what will happen to this body? This body have its self weight and is going to act vertically downward, right? Meaning we have something of this nature. The weight of this body, let's denote it as W. Now, from here, from Newton's third law of motion, we say that according to Newton's third law of motion, to every action, there's what equal and opposite reaction. Meaning, for this weight we have an equal reaction, and the equal reaction in this case, we have it to be something of this nature, and we denote it as R. It's either you use R or N. Anyone you are using is correct. Now, this diagram is for when your body is on when your body is on horizontal surface. You get? Now, you want to look at the concept whereby your body is on inclined plane. How does it work? Hope you are getting the idea. Now, this is it. First thing first, draw your inclined plane. It is this orientation of this body that you are bringing here. You are introducing this guy here to the inclined plane, and this is how it works. Let's say you have your inclined plane in this manner. This is my inclined plane, right? Now, it is inclined. What's the idea? When we say inclination, what does it mean? There's the angle. We are referring to a particular angle, right? Now, let's call that angle theta, or let's use alpha. Let's use alpha. I said earlier that we are bringing the orientation of this body to this place, right? Now, for this body will also act on this inclined plane, and it will act in this manner. We have our body like this. This is our body. From here, you observe that this body is having a weight of this nature. Right? The weight, then we have the weight has opposite reaction. You have it to be like this. This is W. Right? Now, what I want you to know is that it's not possible for your weight to act in this manner. It's not possible for your weight to act in this manner. The question is why? The question is, are you getting what I'm saying? It's not possible for your weight to act in this manner. This weight that you are seeing here is hypothetical, meaning it is an absorption made. You get what I'm saying? We are bringing this case. Okay, let me use case 1 here. Let me use case 2 here. Now, for case 1, we are using the idea of case 1 to explain case 2, since that's what we are familiar with. It's what you are familiar with, is to move further, to expatiate. Now, that's what we are doing here, basically. We are using case 1 to explain case 2, right? Now, from here, we now observe that, is it proper for my weight of this mass here, this body, to act in this manner? The answer is no. The idea of weight is that weight always acts at the center, and it will act vertically. You get? It will act vertically. Now, by vertically, it means the actual weight is coming in this manner. Are you getting the point? The actual weight is coming in this manner, and this one is not the weight. So what this actually means is that this is called the y-axis. Why do you think you are solving? You will always solve in the vertical component and horizontal component. You've never thought of it before. when it comes to friction, we now say that as far as the plane is inclined, we are doing vertical forces and horizontal forces. Why do you think you are resolving both in vertical and horizontal? This is where the idea is coming from. This plane that you are seeing here is actually the y-axis. You need your reference line for y-axis and your reference line for x-axis. So this line here, you can actually relate it to what we call the y-axis. Okay, we will go back to that later. But with this now take note that this angle inclined, this plane, this was the angle being inclined to the plane. Automatically, you have your angle to be here, meaning geometrically, you have alpha here too. Do you understand the concept? Do you understand what I'm saying? The vertical axis, I said this is the vertical axis. Let's call that y. Mind you have your reaction acting on the vertical axis, so you still have a force here. Don't forget that first. Let's reference this to x. Now from here, the vertical axis and the weight of the plane, there is an angle between them, right? From here, don't let me introduce this yet. Looking at this vertical axis and this weight of this block, which is w, you observe that you have an angle between them, right? Now the question is, what will be the value of the angle that is inclined there? This is the angle. So generally, what it means is that whatever your angle is for the initial question, then you have that same angle being in the vertical axis and the weight of the body itself. Any questions so far? Any question? You get the concept there. So that's it. Just now, if you understood this concept very well, that's what we'll be replicating as far as what's it called? Friction is concerned for inclined plane. Right? That's the first thing to take note. Now, let's stop. What you need to know again is that, we said we are talking about friction. What does friction mean generally? Friction is the force that opposes the motion of a body, right? Now, if this body, I'm applying a force of P kilonewton. Let's say I'm applying a force of P kilonewton. Don't forget, this is case 2. Then I have this force, obviously, to be what? If this is the initial force, external force acting on this body, then this force becomes what? The frictional force. Then the frictional force, that's F. And mathematically, what's your frictional force? Mu R. We said there's a relationship. What brought out what we call coefficient of friction? We said there's a relationship between frictional force and the normal reaction. We are saying that mathematically, your frictional force is directly proportional to your normal reaction. From the idea of mathematics, this proportionality will go away and you introduce a constant. So the constant coming in is what we call mu, and it's called coefficient of friction. So you are saying that F is equals to that mu multiplied by R. Call this equation 1, call this equation 2. So from here, I can substitute the frictional force here to be mu R. Is that correct? Yes. Frictional force is still the same thing as mu R. Now let's get started. Let's solve that question. You see what I'm saying? Okay, now let's list out the parameters given to us in that question. What are we giving? Giving data. Giving data. We are giving the weight to be 1,500 Newton. What else? What are we giving? We are giving the coefficient of friction. Take coefficient of friction to be what? 0.3. Mind the coefficient of friction has no unit. Why? Because from here, by the time you make the sorry of the formula here, then you divide both sides by R. Therefore, this cancel this, right? Then mu, which is the coefficient of friction, becomes F over R. What's the unit of force? Newton. What's the unit for normal reaction? Newton. This cancel this. So no SI unit. No SI unit. So that's the idea. Alright, moving on. What else? What's the angle? We are given 20 degree. From there, full stop, right? There's full stop there. After all this data. Now, with this data, let's draw our diagram. Do you understand? Or how should we do it? Should we continue listing the data? Okay, let's continue.
Find the force required to push the block.
Okay, find the force required to push the block up the plane.
When the line of action makes
Okay.
an angle of 30
Okay, now this is the idea. As usual, it is expected that I'm going to have an angle. But in that question, I'm having two angles, right? Now, the initial angle that I'm expecting is this 20 degree. But the force now, the question is not telling you that that force has an angle. It's one angle. Do you understand? So therefore, by saying we don't know the force now, let's denote the force as P. Let's say the force P is unknown, right? And the angle of the force is given to be what? Let's denote it as theta. Theta is what? 30 degree. Is that all? Do we have another data there? That's all. Okay, this is the guy I'm looking for, P. Now let me draw my diagram. Just have it in mind that this is what I'm replicating back. This is where I'm coming to. Now your horizontal plane. What's the angle inclined to the horizontal? From what you read here, 20 degree. Then there will be a body. What's the body in that question? A block. Okay, the body in this case is a block. What's the weight of the block? Okay, 1500 Newton. 1500 Newton. Then if I'm having something of this nature, I believe we should know why. Saying this is my y axis. Any question on that? From what I explained here, any question on how I got this y axis? No question. Okay, from here, there will be a normal reaction, right? Normal reaction. Let's denote our normal reaction, which is R, right? Unknown. Now, from here, what will be the angle here? 20 degree. From what we explained here, we said geometrically, the initial angle given from the question is corresponding to the angle between the y-axis and the weight of the block, and that's it here. This is the angle. So that's what we did here. With that being said, now from here the question has said what's the weight? Read the question.
Find the force required to push the block.
To push the block up the plane.
When the line of action of force makes an angle.
Alright, the question was specific by saying to push the plane. The force is what? Pushing the plane. That means the nature of that force is in form of push. You know, I said force can be a push or a pull to change the state of a body. Now, but for that question says that this particular force, the nature of this force is in push. Now, what will be the how will I indicate the force here? First of all, let's come back to this place. When you have something of this, call this 1, call this 2. From 1 and 2, which one is push? Which one is pull? 1 is push, 2 is pull. Depending on how you view it. You get? Now, if I'm here now, 1, I'm pushing it, right? 2, what happened? I'm pulling it. Same thing, if I'm here, I'm pushing it. From here, I'm pulling it. So depending on how you view it, how question comes. So for this question, I'm taking my force to act in this manner. Let's say I have my force like this. Right? I'm pushing it. And what's the magnitude? Unknown. That's what we are looking for. But this force, we said it earlier that it has what? Angle. And the angle is what? 30 degree. So you have to indicate here by saying 30 degree. Probably you are going to draw your force diagram again. Let's say we have something of this. This is 30 degree and this is P. So with this illustration, you are saying that this force P is pushing it, right? And it's inclined. The force is inclined 30 degree to the horizontal. You understand? That's what the question was saying by line of action. So any question so far? All right, now from here, solution. Solution. You consider your vertical forces and your horizontal forces. There's something that we are yet to include here, and you all did not notice that. You can tell me. Eh? The what? You're saying the frictional force. If my force is acting in this manner, then the frictional force becomes what? Opposite. It's going to be opposite of the force. So let's say I have my frictional force in this manner. Though your frictional force acts tangential. So let's say we have it like this. Don't get yourself confused. So we have it like this. Then frictional force is the product of mu times r from here. Alright, let's solve. Solving for the vertical component and the horizontal component. For your vertical component, it means summation f of y equals 0. What it means is that I'm considering all the vertical forces here. I'm equating the vertical forces to 0. Are you with me? Now, how many forces do we have here in general? How many vertical forces do we have here? If you are seeing inclined force, you can surely resolve your inclined force to your vertical force. Are you with me? So from here, I'm having this force, this p kilo. Let me denote it as p kilonewton, since force is measured in newton. Oh, sorry. We are giving the initial force from the question is measured in newton, so this should be in newton. All right, I'm having this force here. I'll be considering this force as vertical. Why? Because I can surely resolve to vertical component. It's an inclined force, but I can resolve it to the vertical axis. So this becomes part of the vertical forces. So I'm saying this is 1. I'm having this one. This is also 2. This is 2. Then this one will make it to be the third one, right? And that's all. That's all. Any question? 1, 2, 3. Now let's consider this first. Let's consider this first. Now that will be what? Don't forget, you are solving in the vertical component. So this going in the vertical component, it will be what? P sine 30. Do you agree with what he said? He said P sine 30. How do you get P sine 30? How do you get P sine 30? Anybody? Do you have question? Now, from here, it is always advisable to bring out your inclined force. Bring it out. You can bring it out separately and resolve both in vertical and horizontal. So when considering the vertical, you then bring the value you've gotten, you bring it back here. You get what I'm saying? Now let's bring this out. From here, you should have something of this nature. Let's say you have something like this. This is y, this is x, right? Then this is your force, and the intensity is p newton. Then what do you have here? 30 degree. What we have here, is there any difference with what is here? Is there difference? No difference. I brought this diagram, this force here, this component, I brought it out from this diagram so that it will be easier for us. Now let's resolve this in the vertical axis, and the vertical axis and horizontal axis. Now for vertical axis, what will be the value? What will be the value? You guys have not been taught resolution of forces. So what will be the I said it the other day, you guys have forgotten. It is very tricky. Just use logic to learn it. You get? Now, this is my x axis, right? This is my y axis. The question is, where is your angle being inclined to? I want the cross answer. X axis. Since your angle is inclined to the horizontal, it means horizontal will take cos. Are you getting it? Horizontal becomes cos, while vertical becomes sine. Now, since I'm considering vertical, this is it. The difference is that we have cos, we have sine. One will be cos, one will be sine. Are you with me? Now, since this angle is being inclined to the horizontal, then horizontal becomes cos, while vertical becomes sine. What if we reverse the case by saying that the angle from the question is inclined? Looking at this diagram, where is the angle inclined to? Y-axis, meaning that for this guy here, vertical becomes what? Cos. Then horizontal becomes what? Sine. And that's it. You get? So in general, what we are saying is that anywhere your angle is being inclined to, that axis takes cos. Okay, let's move on. Then from here, back to the question, we have 30-degree here. So for vertical component, f of y, it becomes what? For vertical, what do you have? P sine P, which is the magnitude of the force, sine 30-degree. My question for you guys is, why am I saying sine 30 and not cos 30? Because it is inclined to the horizontal and not vertical. So in this case, f of x should be what? P cos 30-degree, and that's it. But now, you've not included your direction, your sign convention. Now, when it comes to sign convention, what you just need to do, relate the idea of your Cartesian coordinate. Though in some cases it varies. Your interest should be the arrow. You know, the force here is P, and the arrow of this force is acting downward. You get? Bring it back to this. From here, from Cartesian coordinate, this is positive, right? This is negative. This is positive as well. This is negative, and this is y-axis. This is y-axis. This is x-axis. Now from here, now look at this thing very well. I want you to observe something. By the time you resolve this force to the vertical, where will the arrowhead be facing? Down. Since it is facing down, what's the sign? I'm having a negative sign here. Hope you are getting the concept. This arrow, by the time I resolve to the vertical, this is it here, Abi. Just imagine that you are taking this arrow, you are dragging it to the vertical. Then you will now observe your arrowhead is facing down. Since it is facing down, come back to this place. What is the sign? Negative. Meaning for your f of y, you need to include the negative sign. Meaning that f of y is equals to negative p sine 30-degree. And you are done resolving the force here. Now, same idea. Use that same idea for your f of x. Will it be positive or negative? Positive. Why is it positive? Because by the time you bring this arrow, you bring it down, and you are taking it to the x-axis. The direction of the arrow, where is it pointing at? Is it the positive side or the negative side? Positive. This side. Positive. It will be looking at this side, and this side is what? Positive. So from here, what do you have? Positive. Are you with me? So that's how you introduce your sign convention to your resolution of forces. Now, back to this question. I'm considering summation f of y. By summation f of y, all vertical forces. Now, for this man here, what will be the vertical forces? You know, this guy here, I have to resolve to the vertical axis, vertical component. So what will be the magnitude now? Just tell me. Minus P sine 30-degree. Don't get confused. I just wanted to know, like, to be sure about it. You get? Now, from here, I have minus P sine 30. So I'm done with this, right? The next one is what? I have this also. I have the weight, which is 1,500 Newton. But this weight is also inclined at 20-degree. You apply same idea here. From here, it becomes what? Or should you still bring it out? It will be what? Not just cos 20. 1,500 cos 20. What will be the sign? Positive or negative? Negative. It is negative. Why? Because It is acting down. It is acting down. So that's it. From here, you have negative 1500 cos 20 degree. Then the next force is what? The reaction. Then that will be what? It doesn't mean. Exactly. Plus R. Plus R equals 0. We said we are considering all the vertical forces. This R, this is a vertical force. This is inclined force. This is an inclined force. This one too is an inclined force. What we only did here was that we converted these two to vertical force. You get? Then we equated it to 0. Now let's solve. From here, what do we have? Let's solve our equation. Sin 30 is what? That's 0.5. Then we have negative p 0.5. Okay, let's write it this way. Negative 0.5 p minus 1500 cos 20 degree. 1400 and please don't approximate to 1409.54. Then plus r, yeah, let's go with it, plus r equals 0. Now from here, what you should do from here, make p the surrogate of the formula. You know, we have two unknowns here. You can make p the surrogate of the formula, or you make r the surrogate of the formula. But from here, let's make p the surrogate of the formula. Okay, r. Let's make r the subject of the formula. Then it becomes r is equals to, of course, negative sign will go to the other side. What do you have? Positive 0.5p plus 1409.54. For this equation 1. This is what? Equation 1. So what you just did here, it means you derive an expression for your what? Normal reaction. That is, by the time I know the value of p, you can get normal reaction. You get? So this is just for vertical component. Now let's solve for horizontal component. Let's solve for horizontal component. But let me explain how we got negative 1500 cos 20 degree, because some people might not still understand it. So this is how it works. Just from what we did previously, you are going to bring it out. Then you bringing it out, you can relate it to something like this. Okay, let me do this way. This is 1500, and this is your angle 20 degree. This is y, this is x. You can compare this, the force here, the 1500 Newton inclined to the vertical being 20 degree. You can relate it here, and they are the same. You get? So by the time you solve this, this is negative, this is positive, this is also negative. Then f of y here, what's our f of y? Negative 1500 cos 20 degree, and that's how you got it here. Then f of x should be what? I want you to tell me what your f of x should be. Negative 1500 sine 20 degree. So keep this value. This is what we use when resolving our forces in horizontal components. Okay, now let's solve for horizontal components here. For summation of f of x equals 0. Same idea. Identify how many horizontal forces do you have. From here, I have 3. I have this p Newton, which I can resolve to the horizontal component. I have this weight, this self weight of this block. I can also resolve that to the horizontal. Then I have this frictional force. It's acting horizontal. Now let's solve. For the first one, we've solved it earlier. What's the value? That's what? That's p cos 30 degree. Solving this to the horizontal component, what do you have? You check your book. P cos 30 degree. Then this one here, this is it. Negative what? 1500 sine 20 degree. Then your frictional force. Now your frictional force, will it be positive or negative? Negative. Why is it negative? Because it's going like this. Force of this nature is negative. Why this is positive? This is negative. Frictional force can be substituted as mu times r. What's the value of mu? It was given from the question. So negative 0.3, open bracket, the expression here from equation 1. So let's substitute the whole of equation 1. 0.5p plus 1409.54 equals 0. Any questions so far? Okay. Don't get it complicated from here. Let me just substitute negative mu r equals 0. This mu r means your frictional force, and it is taking negative. Why? Because it is acting in this manner. So from here, call this equation 2. From equation 2, you can substitute the expression for r from equation 1. Then it becomes p cos 30 degree negative 1500 sine 20 degree minus the value of your mu 0.34, just 3, open bracket, your equation 1, which is your r, that's what? 0.5p plus 1409.54, and that's what we did. So now let's open up your bracket. What do you have? Cos 30 is what? 0.86p. Okay, 866p, right? Let's go with this. That's all. 0.866p negative. What's the answer to this? Let's confirm. 513.7003. Then open up your bracket. What do you have? 0.15p plus this times this. What do you have? 0.3 times 1 for 09.54. Hello, please, let's press our calculator very well. 422.86 equals 0. We are following equation 2. Any question? That's true. Minus. Then from here, we have just a variable. What's that? We just have, let's fast speed this. From here, you can see from equation 2 now, you only have one unknown value, which is p. So you can make p the subject of the formula. From here, collect like terms. It means that 0.866p minus 0.15p equals this and this. We cross over. Then it becomes 422.86 plus 513.03. Let's press our calculator. This subtracted from 0.716p is equals to the addition of this 935.89. Therefore, p is equals to, divide both sides by 0.76. That's 935.89 divided by 0.716. And this is equals to what? 1307 point what? 11. What will be the unit? Newton, yes. Okay, from here, P is equals to 1307.11 Newton. And the question says, what was the question? The force required to push the block up the plane. Now, that's what I'm interested in. The force to push the block up the plane, right? Now from here, we denoted that force to be P and we got this. So now like no, if actually this force will push the block up the plane, you go back to the theoretical explanation on friction that says that before your body can start moving, before you acting a force on your body, your interest is that you want to push the body, you want to set the body in motion, but friction will oppose the force you are acting on the body. And if you can remember, when I explained statics, no matter how the force you apply, static frictional force will find its way up to that force, meaning your body will still be in a stationary position. But the moment your frictional force get to the maximum limit, maximum value, then by the time you apply a force to that body, then the body will start moving. Now to check, if your frictional force is less than this P, then this body, this force will push it up. But if otherwise, this force will not push it up. Now let's check. Mathematically, we said frictional force is equals to what? Mu R. What's the value of mu? 0.3. What's the value of R? We've not solved the value of R here. From equation 1, let's substitute the value of P that we got. And that's 0.5 times, okay, let's say into bracket 1307.11 plus 14. Let's get the answer. What's the answer? This is equals to 263.1. So this is the value of your R, meaning that 0.3 times 2063.1. What's the answer? What do you call it? 618.9 Newton. So what this means is that the maximum force, the maximum value of this frictional force is what? 618.9 Newton. Obviously, if you apply a force of 1307.11 Newton, block is going to what? Push. You get. But in a case whereby I'm applying 500 Newton, what will happen? It will not push. So in essence, what you are saying is that any value of force greater than 618.9 Newton will push the block, and that's it. That's what the question wants you to verify, and you've done that. So some question might ask that comment your answer. That's why I just showed you guys this. So if the question says comment your answer, you quickly use this to back your answer up. You get, and that's how it works.